discussion of metapyquod, and particularly we're going to look at metapyquod-dev today. So just where are we starting here? Here we're on a Mac system, so if we look at the uname on this system, okay, uname-a, we can kind of see a little bit about this system. This is a Mac OS Big Sur system, but we can see here this is an x86-64 system, right? And we have Python on the system, so the system installed Python is version 2, right? And you never want to use that pretty much. If you're running on Mac, you want to use Python 3. So we do have Python 3 on here. I got it through Homebrew. So if I look at that, it's going to be version 3.9, right? And if I run Python 3, let's say, okay, and I import metapy. So I want to do some homework for my class and get metapy. Well, I don't have it. So now I have to start down the path of, oh, well, I have to get metapy. And what I saw when we started the class, and even on throughout people starting to work on the projects, was I'm having trouble with metapy, especially on Windows, but really even on Mac, or I guess even on Linux systems, it's like, well, it won't build. I'm having build problems, or I'm having hanging problems. And the instructors even recommended, well, we're going to grade under Python 3.5, so really you should try installing Python 3.5. Or you could use Anaconda, or you could use any number of things, but there's just way, you could say too many combinations, or at least a lot of combinations of how you might get this and what kind of environment you might have, what kind of libraries you might have. And then, say you get to MP 2.4 and you want to do, some kind of new ranker and you want SciPy. Well, now you're starting all over again. You've got to figure out how to get SciPy. Okay, so how do we solve this? So we're going to talk about metapyquod-dev, which is a packaged version of metapy and some other dependencies in a Docker container. So we have Docker running up here, Docker for Mac. There it is, and we can see, okay, we've got the Docker command line utility here, right? So that's installed, that's all ready to go, but now what do we do? And why are we doing it? So we kind of looked at, okay, our Python version, we have Python 3, 3.9 with no metapy installed. So what I'm going to do here is I'm going to look at metapyquod-dev's repo, and there's a nice, easy getting started guide there under metapyquod-dev. Okay. There it goes. Okay, look under metapyquod-dev, and there is a very nice little easy way of getting started. If you're on Windows, there's a run.bat, and if you're on Linux or Mac OS, there's a run.sh. I can't get away from knowing how to use the command line, understanding what a current working directory is, for instance, and how to run a little script. You're going to have to be able to understand that to work with just about any tool in programming, so hopefully you're good there. Very simple script. All I have to do is kind of get this or download it. I'll just copy the context of it here and make it into a script here of the same name. Okay, very easy though. Make sure it's executable. Okay, and run it. So what is this going to get for me? Well, if you haven't already downloaded it, what it's going to do is it's going to download the image of metapyquod-dev with Python 3.8, metapy, scipy, numpy, and a whole bunch of other dependencies that you can read about there on the repo. But we'll see what happens. So here I do run.sh. It's going to actually go ahead and download it, which we will fast forward closer to the end here, and we can kind of see how this works. But talking a little bit through the end of it, what Docker is, and I talk about this on the repos README, is another way of, or another attempt to deliver write once, run anywhere. Okay, Java tried to do it, virtualization does it to an extent, and Docker tries to do it in a particular way where you can package an application, all of its dependencies, and even the OS level dependencies that your application needs, all in what's called an image, and you run it in what's called a container. So the container is, the idea of the container is almost like just a process that's running. So the process loads into memory, it has state in memory, but when you exit the process it goes away. So keep that in mind, because it's kind of important and you don't want to get yourself into trouble by thinking that things are going to stay around after the process exit. But we've seen now I've run my little run.sh script. It's downloaded the image for this container, and it has started an instance of the container. So before we looked at uname, so now if I look at uname, so I've started the container. So now I have a container. My prompt has changed. So I'm root. I'm not root on my Mac here, but I'm root in the container. So if I look now at uname in the container, now this won't be the same type of result that you'll get everywhere. You'll see, it's still an x86 64 system, but now it looks like it's running Linux, right? So in fact, Docker on the Mac runs a Linux environment within a small hypervisor within a virtual machine. So now I actually have Linux running on my Mac by virtue of running Docker, and I've run this container, which looks like it's running in Linux, but it's a isolated instance of Linux that is only available to my application and to this process, really. And what I have in that image that I downloaded is a bunch of tools. So we looked at Python before. So now if I look at which Python, okay, I'm user local bin Python, but which version is it? Now it's Python 3.8.6, which is in the image, which was just downloaded. Now if I run Python and I import metapy, hey, look, there it is. It worked. So now, in fact, within this image, I had this on my Mac, but within this image I have Git. So I can git clone, if you didn't have Git before, now you do. So I can go ahead and git clone my MP 2.4 assignment, for example. So GitHub MP 2.4 private. Okay, downloading it, and if I look here, I've got that folder there. I've got my code in here, and all I have to do is Python, search eval, config.toml, and it runs. I didn't have to mess with pyenv. I didn't have to worry about what the build scripts are going to do, whatever the CMake scripts are going to do within metapy. All that's been taken care of for me. It's loaded into the image. It's done once. It's a little bit of a hefty download. It's about 500 megs, but it comes with all those things. It also includes some other dependencies that maybe you ended up using in some of the other assignments, like SciPy or NumPy, which I think is actually a dependency of metapy. But these things are already in there. Matplotlib, there's libopenblast, and actually a Fortran compiler, which is just a side effect of having to build the thing. But that's it. You're done. I can't take 100% credit for this because somebody actually suggested way back at the beginning of the course, hey, instructors and TAs, have you considered providing a Docker image of this? And I was like, well, I didn't have too much trouble getting it going, but I could see how some people would, and I definitely had experience like they did when I actually went to try and make these containers. But the idea was there, and I said, hey, yeah, that's not a bad idea. Maybe we can make that part of my project, and so there it is. It works. So let's get a little crazy now. This is easy enough, or maybe expectable enough to run this on a Mac. But so one of the challenging things that I actually did as part of the project was say, you know what, Raspberry Pi is pretty popular. It's a decent chance that maybe somebody has a Raspberry Pi that they've been toying with, lying around with an SD card in it. So maybe I can make it to where they can actually do this on there. If all they've got is their Raspberry Pi toy and their Windows box, and I was like, well, getting this all going on Windows doesn't sound like fun. Maybe I want to just try this on my Raspberry Pi. Well, you can do that. So I can actually, I have a Raspberry Pi 2 set up. So there's the original Raspberry Pi and the Raspberry Pi Zero, which run ARMv6 chips. It will not work on those, and you probably wouldn't want to, but it will work on a Raspberry Pi 2. Now, So I'm going to SSH to my Raspberry Pi 2 here. Of course not. Oh, because I'm still in my container, right? Let me talk about that a little bit real quick. So you'll notice that the container looks like I'm in user source app, right? So if I, ls user, I'm looking at, the root, or if I ls root, I'm looking at the root file system within that container's image. So you don't want to edit or change anything up outside of that image because, like I said, this is part of the process. When I exit it, by default at least, it's going to go away. What I do have here, though, within user source app is that directory is actually mounted or mapped to my documents directory on my Mac. So if I open another terminal window here, I can kind of show you. So if I look in documents, I see the same thing, or rather in documents within MP2 for private, I see the same thing. And in fact, we did that get within the container, if you notice. So we did that within this root in the container environment. So that's bidirectional. The way the run.sh script sets it up, at least, is your workstation, your local desktop, and the container share that path that you started in. So what that means is that you can use Visual Studio Code, for example, to very easily edit. So I can, add folder to workspace. I can go over here. I can, add MP4 2.4 private, and yes, and so now I have my Python files in there, and I can edit them. Yeah, sure. So I can go ahead and edit that file, work on it however it is that I want, and so I can say, now I'm running awesome queries. Thank you, Visual Studio Code. Running awesome queries. I can do what I normally did with whatever my GUI editor in, whether it's in Mac or Windows. Go ahead and edit those files, and now I can go run the same thing there, and hey, now I'm running awesome queries. So you can carry on development more or less exactly the way you did before, but you don't have to worry about gathering all the dependencies. You can still use Visual Studio Code or PyCharm or whatever it is that you're using on your workstation, edit the files in place, but you can run them and test them within this environment. Now, the one caveat to that is the debugger that you would normally be able to use, and hopefully you are using a debugger when you're doing development because it really improves your ergonomics and your productivity. But the debugger that Visual Studio Code here has, by default anyway, won't be able to see this Python process that's running in a container. It's almost like it's running on a separate machine, which you can do, like if it was mounted over NFS or something and you were editing your files that way. You can do that, and in fact you should be able to do that with the remote debugging capability in Visual Studio Code. But that's a little bit more advanced. So what can I give you? So what I can give you is WebPDB. So we did a couple of things within this container to make using it much more practical. So if I look up WebPDB, it is a web-based Python debugger. So what happens is you can debug your code in a web page that looks like this. So if you know you want to stop your code at a particular place, okay, I'll come back over into Visual Studio Code and say, right before I run my awesome queries, I want to start the debugger and inspect the state, right? So I can go ahead and save that. If I now run this code, it's going to pause at that line. It's like, oh, well, I've started the debugger. Well, how do I get to the debugger? Well, I just open my browser and go to HTTP localhost 5555, and now I have the debugger. So now I can use the debugging console just or almost as well as you could say within Visual Studio Code. I could say, what's the value of query? Okay. Query is a metapy document, query dot, I forget if you could do this. Can you do query dot content? Okay, it's a bound method, so it's query dot content, and this is really valuable too. It's like, I don't know how this API works. Let me play around with it. Well, the debugger is really, really useful for that. Okay, there is no content for the requested document because I haven't actually put it in there. Yeah, so there you go. So now I can run the debugger. I can go ahead and say continue. The debugger will finish. It runs my awesome queries, and there's my result. So that's terrific. You can also run Jupyter. You can run a Jupyter notebook within the container. It passes through the appropriate ports. Okay, it's going to tell you right here that here's your URL. Doesn't open the browser for you. Maybe a little bit less convenient, but not so bad. There's my Jupyter engine running there. I can create a notebook if I want to. Use the notebook, for example, from mp2.2 to do my web scraping assignment, right? So the idea is, again, all the tools that you might need to work with MetaPy, play with it, do some of the assignments like in the UIUC CS410 course, all of those are bundled, packaged, available here for you to use. Okay, so I was talking about running this on a Raspberry Pi. Now that we've kind of explored the idea of the container, let's get out of it. So now I'm back on my Mac. So now I want to SSH to my Raspberry Pi 2. And again, so this is a Raspberry Pi 2 that is a, I think, 900 megahertz ARM v7 processor. CPU info, right? You can kind of see there. Check me if you want to. ARM v7L, right? And if well, okay, so while we're on it, so it has 1 gig of memory, which doesn't sound like a lot. It's like, can this thing even run this stuff? Well, we'll see. So yeah, so less than 1 gig of memory once it's taken a little bit away for the graphics subsystem. So this is a circa 2015 $35 single board computer. So what do? Well, I do exactly the same thing I did. So if I look in documents, here on my Raspberry Pi, oh, by the way, so just so we're not faking anything, here's my uname. This is Linux on a Raspberry Pi. This is Raspbian in this case. ARM v7L, okay. Python, which Python are we dealing with? In the host system, Python 2.7. Do I have Python 3? Yeah, I have Python 3. That's Python 3.7. Okay, I had 3.9 on my Mac, right? Which one is that? Okay. Okay, so that's user bin Python 3. Now I could do some of this with paths, obviously. You can, play around with this, but here's my Raspberry Pi 2, or I can use Raspberry Pi 3 or Raspberry Pi 4, not the original Raspberry Pi or Raspberry Pi 0, but here it is. So if I'm in documents and I look and I've pre-staged a couple of things. I got my run.sh script. It's exactly the same script as we saw before. It's going to do exactly the same thing. And I run it. Now again, it's going to take a little bit of a time to start up. I've already downloaded, and what Docker will do is it will cache the download of an image if you've already downloaded it before. And again, this is a 900 megahertz, quad-core ARM 64-bit processors running a 32-bit OS now from 2015 for $35. So it's a little bit slow, but it is eventually going to start that container. And guess what? Now I have exactly the same environment that I had before. And so if I ls, I've got the same files there in the directory, so I can change into my MP 2.4 private clone that I set up before, and I can do the same thing. Python search eval config.2ml, and it's going to run. It's a little bit slower, but totally usable. So if I have a Raspberry Pi 234 laying around and I don't want to mess with my Windows box, hey, I can run and install this container on my Raspberry Pi and use it there. Pretty neat. Now, okay, I don't have a Windows box to demo with you. The one Windows box that I have in the house was actually an old tablet with an Atom processor that is only 32-bit, and I can't run this container on that, not because it wouldn't run. It actually is compiled for i386. If you've got an i386 Linux box laying around, it'll run on it natively, but 32-bit Windows, Docker refuses to run on it. Docker only supports 64-bit Windows operating systems. So I couldn't actually demo it for you there. So I'm like, okay, well, let's get really crazy. There's a site called labs.playwithdocker.com. All you have to have is a GitHub, I'm sorry, not GitHub, but a Docker Hub login, which you can get for free. And you can go to this site and start. And this gives you 4 hours to play with a Docker environment that you can do whatever you want. Whatever you want means that it includes running this container. Okay, so I don't have my run.sh script here, but I'll do exactly what it is. So here's, for argument's sake, okay, my uname. This is a x64 Linux system. Looks like it's Ubuntu. Okay, what Python's on here? Okay, well, there's no Python on here. Is there a Python 3? I don't think so. Oh, we actually bought Python 3. Python 3 3.8.5. Is metapy on here? No, of course not. Okay, no. Okay, so we'll get out of that. And so instead of staging my run.sh, I'll just go ahead and do this. Do what it does. So Docker run -it says I want an interactive session and I want to attach my terminal to it. Okay, -v pwd user source app. Now, if you noticed over here, you can kind of see in the screenshot, we were in user source app within the container. So this is telling me take my current working directory and attach it to user source app within the container. I'm not going to bother with forwarding the ports here because we're not going to use Jupyter or WebPDB. I'm not sure exactly how that would work anyway. But again, we're here in a browser and I have a terminal that has a Docker environment running. And we're going to stand up metapy and run some metapy code, which may or may not blow your mind depending on what you expect here. So I'm going to just put in the identifier for our image, metapyquod-dev, and I'm going to use the Python 3.8 version because that's what we've been playing with. There is also a compilation of this up in Docker Hub for Python 3.6. If for some reason you need to use Python 3.6 instead of 3.8, it's closer to 3.5 at least. If you're worried about passing the auto-grader validation, that might be a better way to go. But there we go, Python 3.8. Managed to get metapy compiled and running in it. For my experience and what I've tested so far, they behave exactly the same. Probably or possibly a result of the fact that they're built in the same environment and not so much the actual Python interpreter version differences. But so far, the Python 3.8 build has been able to run all of my assignments and do everything that the Python 3.6 does. Python 3.5 doesn't have an official Python image in Docker anymore. It's old enough that they're not actually providing the images for that. So that's why we went with Python 3.6 and Python 3.8. But here we go. And I've typoed something, as always goes. You probably spotted it before I did. Transposition. It's going to download it just like we saw before. Okay, and here we are, exactly where we were on the Raspberry Pi, exactly where we were on the Mac. We have a container. Now, I'm not going to use my Git credentials in here because, as it warns you in the login banner, that this is a sandbox environment. Somebody could theoretically snoop, and we don't want to, be responsible for you, getting your account hacked. But so what I can do is I've got a little bit of code from MP1, right? Just a little bit of Python code that uses metapy, creates a document, creates a tokenizer, and then parses it. So I can do that. So if I just start the interactive Python interpreter, and our first line here is import metapy. Does it work? Hey, it does. So we could take the rest of it actually and run it, and we can see there it runs just fine. There's our output, parsed sentence tags. Could use a tokenizer, could use a stemmer, whatever it is. The whole environment's here. Running in a browser on a remote server for free. I've got 4 hours to play with it, however I want. Probably wouldn't be the way you would want to do your homework assignment, but you theoretically could, right? In a browser, using this container, and in a nutshell, that's metapyquod-dev, that's Docker, right? Once run anywhere, and we managed to use it for getting a metapy environment.